So I'm going to be going over some Kicad basics. So when it comes to Kicad, starting in a schematic and finishing off with your final product, there are three main steps. The first step is kind of getting all your components and your wiring together in the schematic editor. Then from there, you'll take it to the PCB editor, where you'll kind of map it out on the board and how you want it to look, and you'll also be able to see a 3D model of what the final product is going to look like. And the third step is actually shipping it. So you're going to be converting all those files to Gerber files, and you'll be sending it to a manufacturer such as JLC PCB or PCBWay. I personally use JLC PCB. Just flipped a coin for it. They're both the exact same thing. So to start off, we're going to go ahead and start a new project. And I'm just going to name this new project. And you're going to see we have two files here. We have the schematic and the PCB editor. And for the purpose of this video, we're just going to start off with the schematic. And you're going to see this neat little interface here. And you can move around by scrolling with your mouse or by right-clicking, and you can translate across the page here. And there's going to be quite a few options up here. You have your kind of different scaling options. These aren't all that important personally. These are a little bit more advanced, so you don't need to look at those just yet. And on the right is where we're going to start. So when it comes to kind of wiring your components, you're going to actually need components. So we're going to start off by placing a component, and you can either do that by clicking place and add a symbol, or the shortcut, which I will show you in a second once it's done.
One eternity later.
So there's really not that much to it when you have kind of a schematic or kind of a layout that you already know what you want. You can go ahead and just kind of click A, and here you can either filter, and you already have a huge library of components that you can choose from. So when it comes to choosing components, you have two options. You can either pick one from the library that's already provided, or you can make one. Making one's a bit more complicated, but for the purpose of this video, we'll just go ahead and choose a basic one, such as a resistor, and we'll pick this one. And we're going to go ahead and place it, like so. Now, I'm going to also go ahead and place another one, and I can either go ahead and just left-click right away and click this, or I can also just copy and paste. And now we have three resistors here. Now you're going to notice, actually I'm going to go ahead and just create a simple circuit really quick. So by clicking P, you can go ahead and define a power source. And I'm just going to pick an arbitrary value, 5 volts, doesn't really matter. I'm going to create a quick little circuit. And also, with your power symbols, you can also add ground. I'm going to put that down here. And right away, we already have two conventions that are typically used in industry, which is power symbols are facing upward and ground symbols face downward. That's just so you can easily identify kind of what's what, in a schematic where you have thousands of symbols, it gets pretty messy. So now that we have these basic configurations, we can go ahead and kind of connect them. And you can do that by clicking this wire here and clicking the terminals and connecting. The other way you could do it is by clicking W and left clicking. I personally like to use W, it's a lot quicker. Just like that. And one thing you're going to notice is when you're kind of connecting components, you kind of need an end kind of terminal here. You can't just have a wire kind of just floating around. So I'm left clicking here and it's not working. So you're going to need to connect between two terminals or pins or whatever you want to call them. And right away you're going to notice that these already have names. So we have ground, 5 volts, but then for these components we have R1 and R. R1 is how you identify which resistor it is, and this R can actually be changed for a value. So let's say I want to change it to 10k ohms. So both of these are important. This is to help you just kind of keep track of what the values are and for organization. And this value here is for the next step. When I started out, I would kind of just delete this because I thought it was useless, but it's very important. You want to keep this. And I'm going to go ahead and move this over. Now, for this video, these values are not important at all. Just doing it to show you. Go ahead and change this to 10k as well. Now the easier way is to have your initial resistor, so your R1 over here, set that R value to 10k and then copy and paste, and the 10k is going to follow, but the R1 value is going to increase. So you can never have two components with the same name, and I'm going to go ahead and try that. And turns out you can. But for the next step, just don't. Keep these different. It's helpful. And with that, we have the basics of kind of building a simple circuit. So if we take this to the next step, it's just 3 components with a source, a ground, and you can just order the components off of like DigiKey or something, and you'll get them shipped over, and you can easily just put them on the board. And it's super simple. But let's say you have something more complicated and you want to kind of rotate these, because you're not always going to want these in kind of vertical orientation. I'm going to go ahead and paste one over here, and you can go ahead and click R. R rotates it by 90 degrees, just like that. And I normally find myself having to rotate components. Now, let's say we have a kind of, let's say we have another component, let's say capacitor. So we'll click this C component here, and it's all the way on the other side of the page. Now, instead of, let's say it's also connected to 5 volts, one way you could do it is by doing this, and then kind of connecting it back to here. Now, this is not very ideal. It's kind of, out of the way, and I have all these wires just kind of flying everywhere. So I'm going to go ahead and delete these. And instead, you can go ahead and just going to delete that. Go ahead and define a label. Or no, not a label. That's you don't need a label for when it comes to identifying power sources, because technically that's already a label. So labels help you kind of identify common nodes. So what that means is, let's say I wanted to kind of connect this part here to this part here. It goes all the way on the other side. Or, yeah, it's all the way on the other side. So I'm going to go ahead and define a label. I'm going to call it, I don't know, beats me, positive, right? So now I have this label. That's not a label. I meant this label here. So I have this label here, and this is kind of it's going to become a common point. So, and I want this all the way over here. So I'm going to go ahead and, whoops, get another label. I'm also going to call it plus. Put this here and connect. And connect. Now, what you're telling the program is that these two are connected. They share the same node. meaning that when it comes to the next step, it's going to tell you that these two need to be connected. They need to be common. And also, I'm going to want to connect it back to here, or ground. So I'm just going to go ahead and put ground. Now when it comes to the next step, these two, the program is going to tell you these two parts should be connected. And that's really useful because when you have microcontrollers and integrated circuits kind of just flying everywhere, kind of on one side of the page to the other side, you're not going to want to kind of connect them because then you're going to have overlapping wires and it's going to look super messy. That's what the next step is for. So I'm just going to go ahead and bring this closer. Now that is pretty much the basics. There's one other thing that I would probably mention, which is, let's say we have a microcontroller. Doesn't really matter. I'll just go ahead and, oops. This huge thing, right? Super confusing, a lot of pins, don't really know what's going on, can't really know what's going on without looking at the datasheet. But if you have an application, this is what the Arduino uses, and sometimes you don't always use the I/O pins, not all of them at least. And so what you can do to let the program know that you're not using them is you go ahead and put a no connect flag. And you can put them on as many as you want, and it's going to know that these require no connections. So the program's not screaming at you for warnings and letting you know, hey, there's this connection here. So that's pretty much it. For the next step, before you can actually get into the PCB editor, it's this last step where you want to define footprints. What is a footprint? It is a representation of these components in the next step. So right now these are looking really neat, but we don't know the size of them. We don't know if they're going to be through pins or SMDs. We don't know what it's going to look like. We don't know how they're going to connect. So to give them a representation in the next step, we're going to have to assign footprints. And we can do that by either clicking the Assign Footprints editor here, and this is it's a really easy way. I would recommend you to use this, because you can either do this, and you'll have like an overview of all the footprints that you have, or you can go ahead and double click, and see this footprint right here. If you click it, you'll see this kind of book item, and you can go ahead and choose your footprints. But I prefer this because, I'll show you in a second, if you click this, what you will do is put in capacitor, and you're going to see all of these options. So you're going to see the name of the component and then the type. So it's either going to be SMD or through hole. Here, THT. So for this video, let's just use SMD. I don't really care about the size. So I'm going to double click it, and it's going to be applied. And it's automatically going to index you to the next component. And that's useful because let's say we have 3 resistors that all require the same one. Instead of having to double, in the other method, instead of having to double click on all of them, you can go ahead, click resistor, SMD, whatever, double click, and double click, and click OK. And you're going to see, if you choose these ones, you're going to see that it gets applied to all of them. And just like that, you're ready for the next step. You have all your footprints assigned, you have your connections, you have your labels. They're kind of oriented in a somewhat neatly way. You have your ground, 5 volts, and you're set. So I'll see you in the next video.